get on with question number 3 for today. So in this question we have to prove y is log of a minus log of b equal to log of a over b. Okay, so question 3, ln a minus ln b equal to ln of a over b. So just to recall what logarithmic is and how it works, if I'm given the log of x equals to y, this is equivalent to e to the y is equals to x. So the logarithmic term becomes the answer, and then the answer becomes the exponent. Okay, so this is the key principle we would need to know in order to prove the above. Okay, so let's look at what ln a would look like. If ln a is equals to, ln is also the natural logarithm, which is to the base e. If logarithmic or ln a is equal to some value a, we don't need to know the value, it will be some numerical value. From this, applying this principle, we know that the y gets to the power and the x becomes the answer. So we would get e to the a is equals to small a. Similarly, we can say ln of b is equals to some value b, which would imply e to the b, capital B, is equals to small b, and there would also be some numerical value of the logarithmic term of the numbers a over b, and we can call that numerical value to be equal to c. From this, we would say, if we were to take the inverse of it, we would say e to the c is equals to a over b. Okay, so looking at the last term which we got, which was e to the c is equals to a over b, we know the values of a and b since we have gotten them in the first two parts of the solution. So we can substitute the value of small a and small b into this. So we would get from that e to the c is equals to e to the a, which is a which is equal to e to the capital A. This is capital C, and b which is equal to e to the capital B. Okay, so far so good. I hope you're following along. So the next step would be if we remember the property of exponents. So let's say we have any number a to the power of n divided by the same number a to the power of m, we can say this equal to a to the power of n minus n. So that's the property of exponents or exponential property. So we can apply this property to this equation here, and we would get e to the capital C is equals to e to the capital A minus b. Okay, if I were to take the logarithmic of either side, which is saying I would compute the log of e to the c and compute the log of e to the a minus b, I would get c is equals to a minus b. This is essentially because log of e to the a is equals to a. Okay, so since we have gotten this, which is kind of brought us to the final answer as well, since initially we defined c to be able to, or capital C equal to log of, or natural log of a over b, a to be equal to natural log of a, and then b to be equal to natural log of b. So from this we have come, or we've come full circle, you can say. So we started off with the two logarithmic terms and equating their value to some numerical value a and some numerical value b. From that we got the value of the small a's and small b's, and used that to go back into the logarithmic term through the help of random variable c. Okay, so this is how we were able to prove that this identity, which is division for logarithmic, actually holds true. Okay, so they have done a similar method. So ln becomes this, and then this becomes e to the a minus b. Perfect, perfect. Okay,